Example 1. Simple inhibited growth. A big book company notices that the maximum number of copies for a new book is 80 per day. The rate of growth of sales is proportional to the difference of the maximum sales and the current level of sales. In the first hour of sales, 6 books were sold. Approximate the time at which 60 books will be sold. First, we gather the known information and determine what the problem is asking. So we start with our general model. Y is equal to P minus the quantity P minus Y sub 0 times e to the minus kt. We are told from up here that the maximum value is 80 per day. So P is equal to 80. Since it is a new book, Y sub 0 is equal to 0. No books have been sold previously. We are also told that in the first hour of sales, T is equal to 1, there are 6 books sold. That comes from this line right here. And we want to approximate the time, so T here is a question mark, when 60 books will be sold. Now we substitute all our known values in order to solve for e to the minus k. So we place all our known values into the equation, work out the algebra, and take note here that t is equal to 1. That's something to take note of. We have negative 74 is equal to negative 80 times e to the negative k power. And then making our appropriate algebraic moves and simplifying, we find out that e to the minus k is equal to 37 over 40. We substitute 37 over 40 back in for e to the negative k power, and we obtain this equation here. Y is equal to 80 minus 80 times 37 over 40 raised to the t power. Our next step will be to solve for t. Since we are asked to find the time at which 60 books will be sold, we substitute 60 in for y and solve for t. So we're placing y with 60. We subtract 80 from both sides to get negative 20 is equal to negative 80 times 37 over 40 raised to the t power, which dividing both sides by negative 80 gives us 1/4 is equal to 37 over 40 raised to the t power. We take the natural log of both sides, we take the log of both sides, and we have the log base 37 over 40 of 1/4 is equal to t. And let me explain how we go from this step to this step, determining that t is about 17.8 hours. So let's recall that when you have a log of any base, we can rewrite this as log of some base b of x is equal to log of another base a of x divided by log of a of base b. So for this problem, we're going to let a equal 10. So we're going to have a is equal to 10. B is going to equal to 37 over 40, or the decimal 0.925. And we're going to let x equal 1/4, or 0.25. So here we have the natural log of some base, I'll call it 0.925, of 1/4 power. So making the substitutions into our logarithmic identity up here, we have the natural log of base 0.925 of 0.25 is equal to log base 10 of 0.25 divided by the log base 10 of 0.925, and that's how we get t is equal to 17.782 hours. So to answer the question, it's going to take approximately 17.8 hours to sell 60 books.